Hello, welcome to the day 5 of LeetCode coding, and today we are solving a 169, a majority element, and this is the first try I'm solving it, as if in a real interview. I hope you'll enjoy it. So let's get started. Given an array of nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority element always exists in the array. Okay, first we have 3 numbers, and the most common occurrence, like most frequent number, is 3. And here we have another array where 2 is the most common number. Okay, so we have the constraints where n is a number's length and can be the list cannot be empty. The list will have one or more items. Okay. Okay, so there is, and it also says that there is always a number that exists, a majority number in the array. Okay, just like we do every time, let's come up with let's clarify the question. So input we get is an array of numbers, integers. Output is an integer. That's a majority number. Okay, that's our input and output. And here we have 2 test cases. And you can also pause here and write your custom test cases, because it will help you understand the problem better. And here we may have one element. If that's so, we just give that element. My question is, what will happen if there are 2 elements? Which one should we give? Or will we not have such a case? Okay, for now, like in the real interview, probably the interviewer would have given us an answer. For now, I think like if we get such a case, both of them should be accepted. Actually, we don't get such a case because if we look at this, more than n divided by 2, so this is an invalid input because none of the numbers are more than 1, like 2 divided by 2, more than 1. So if we only make this 2, and then it will be valid. Okay. Any other cases? So if you have noticed, our array is also not sorted. It's just any number coming in any order. Okay, I believe that's all we can write for test cases for now, or I don't see any other edge cases. Okay, let's get to the logic. How do we solve it when we go through the array? Basically, what we are doing is counting each element and comparing the count with count comparison with array length divided by 2. We are comparing it. that's that's the two actions that we should do. We should firstly know which of the numbers, like occurrence, counting occurrence of each element, and then comparing that count. Okay, how can we do that? You can pause the video right here and think about your solution, maybe some possible solutions you can come up with. But like I will go on and start with my own ideation, maybe solution. What I'm thinking about is actually using some type of extra space, more precisely a dictionary, where I will be storing every number, like with their count. For example, like 2 here occurred 4 times, and 1 here is 3 times, something like that. At the end of the iteration it will look like that. But before I finish the iteration, I may even be able to find the number which has majority occurrence, because I will loop through the array firstly, and every time I for every element, if it's not in the array, in the dictionary, first, like, it will be empty like this. If it's not in the dictionary, I would say element and then the count 1. And if it is in the dictionary, I will just increment the count of that number. For example, when we reach 1, we don't have 1, we will initialize 1 and set the count to 1. And on the second one, when we come here, we say it's 2, and here we say we have 3 ones, and now we have we increment the count of 2, and so on. 3, for example, here at 4. But each step, when we are incrementing, I also want to compare. While I'm adding, I want to compare. For example, the length of this array is 6, 7. Oops, not here. 7 divided by 2 is 3.5, meaning that at least 4 should be here. Or we can just take 3.5 and compare it with every value we are putting in the dictionary. If you have noticed that when we reach this last 2, we put here 4. At that check, it will return true, like 2 is more than like majority of the elements are 2, meaning that this occurrence is more than the one we are looking for, and we can just return 2 at that stage, and that should work. The time and space complexity. What do you think the time and space complexities of this problem is? Okay, you can again pause here, think about it. Okay, so the time complexity will be big O of n, thinking that n is the length of our array, and array.length. And space complexity will also be a big O of n, because firstly we are looping through each element. That takes like O of n time, and every element we are checking whether it exists in the dictionary, which takes O of 1 constant time, so we will have O of n as a result. For space, we have this new dictionary, that's like in worst cases that will store it actually will store unique values, but still I believe, let me think. I feel like if we have one element that's occurring more than any other elements, we will end up with n divided by 2 space complexity, but we can remove this constants. Yeah, and it will, but anyway, it will end up as n, log of n. Why I'm saying this? Because you may assume like the half of the array or more than half of the array is the same element. Let's say 1, and we have lots of ones, and then the other half will maybe different elements, meaning that we will have n divided by 2 space here. Like for half of them we will have extra space inside our dictionary, and for one we will have just the count and 1. It will end up like this, but we can remove this divided by 2 and it will be space of n. That's what I think. Let me know if there's like any errors. Okay. Now I guess it's time to code. If you wanna code it again, you can pause the video right here. Otherwise, I will go on and start coding. What about our pseudocode, right? I didn't write our pseudocode today. So the first thing, iterate for loop through array, and for each element, if element in dictionary, increment count. If element not in dictionary, initialize count 1. And also if element is in the dictionary, here we want to do the second step. Let me increment count, and also we want to do compare with array length divided by 2. Okay, and we check like if it is true, return the integer element. If true, let's say. Yeah, that's basically what we should do. Let's start by initializing all the also if I want to say like now stop length is 1, let's just return 1. Or okay, let me think. Okay, yeah, we will say if less than or equal to 1, return just just nums 0. Like we will have 1 or more because we'll never have empty array. Actually, maybe we should compare with if I move it here after all the if statements, this case will be covered. Let me initialize the variables. We will have a dictionary or hash map of values. I will call it dictionary. Okay, next we will also have that comparison. How can I call it? Like I want to get the numbers length divided by 2. I am looking for a proper name for that variable. Majority count. My half length or something like that. Okay, let's just say half length. That's basically what we are doing. Divided by 2. Okay, so we have our 2 variables initialized. Now it's time for our loop. For I equals to 0, I less than numbers dot length, and I plus plus. We want to do the following. Okay, here let's say let count equal to 1 for every element that's coming. We will just say like count is 1 for now, and we check if element in the dictionary. If let current integer, which is like element that's current element, will be nums I just like to rename, like instead of using the variable like this here inside the conditions, I just like to assign a new variable this way. If current in dictionary, this is how we can check if it's in the hash map in JavaScript. Yeah, if it is in the dictionary, we will increment the count. We will say dictionary count equals, oops, let's actually also have the count variable, updates the count variable. I will be using it right here. Okay, it equals to dictionary count, and also a dictionary count, actually it should be plus 1, yeah, or I can just say plus equals because it was here, equals to count. Okay, that should actually work. I am updating my count, and also I'm updating dictionary count. Or for simplicity, I can just say here for 1, as I said, like increment by 1 the occurrences. Okay, and else statement we have here. Okay, if not in the dictionary, we will cover. Okay, let me just take it. We will cover this case in our else. If element is not here, we want to initialize. We want to say dictionary count, not count, current. And here is the problem. You see, equals to 1. That's how we initialize it, and everything after the checks. Our count will be up to date, and we want to use it. Okay, we don't touch the count here because it is 1 by default, so and here we check if count is bigger than our half array length, then return the element, returns the current element, returns the element. Yep, that's basically it. Let me just take it and place here. That's basically it for the coding part. Let's okay, it says half length. I don't know this. Is it I misspelled it, I guess. Now it's time to dry run our code. Let's take one example, and as always I'll be writing this. Okay, we have count here, we have current here, that's variable will be changing, and yeah, here, and also here we can add. Okay, so let's take the first example first. So we have these 3 numbers, our dictionary is empty, and our half length for this one is 1.5. We have 3 elements divided by 2, resulting in this, and we are looping through the array. Okay, if the count, what I want to do is actually we are not using I anywhere. Let's use let current in nums, so that we don't have to initialize like here. Okay, it will make it a bit simpler. I'm using another type of a loop. instead of indexing, because I'm not using any indexes, array indexes here. Yeah. Okay. So the first number, we come here, we have the first number. First it is 3, and our count at this stage, let me do this. Our count at this stage is 1, initialized to 1. Is 3 in the dictionary? No, so it is false. Now, if it's false, we move here and we add 1 to the dictionary like this. Okay, we have one item right now in the dictionary, and then we start the next iteration. Now we have the number 2. We set the count to. Oh, also I forgot to check. We also checked here, is 1 bigger than 1.5. It was false, so we move to the second iteration, to the number 2. Count is 1. Is it in the dictionary? No. So we also come here and add this to our dictionary with this line of code. Okay, the next we check again, it's false, and the next number is 3, and the count is 1 by default. Is it in the dictionary? This time it returns true, and it also in the count will become like current count plus the count right here, like plus 1, which will be 2. And here we say dictionary count, the current count also should increment by 1, and also here, like, oh, well, it was like 3. Also here we come here and we say this is 2 right now, and at the end we check 2 is bigger than 1.5, which means we will return 3, and that's the correct answer. What if we have one answer, one number? Length is 0.5. Current is the number itself. Count is the 1. Is it in the dictionary? False. We add it to the dictionary. We say it is like this. Okay. And then we check, is 1 bigger than 0.5? Yes. So we return 3. Yeah, that should work. Seems like the logic is working fine. Let's just I guess it's time to run the project, the solution. Okay, let me do some refactoring. Loop through array. We don't need that explanation. I can just remove this. No need for this. If element in dictionary, it's very clear from the syntax. Increment count, I believe it's clear as well. Initialize count 1. Okay, let me just leave this parts. Increment count and initialize count. Compare. If true, return the element. Okay. Actually, the code itself is pretty much explanatory. And yeah, what I would have done if we had some, for example, invalid cases, we could have returned 0 or null or something like that, or true or false. But for this one, to be consistent, we should return a number. So let's say the case says like we will never have such a case, like invalid case, but if we have one, we will end up here. But if we don't have any invalid cases, we will return before exiting this loop, because we will find a number that occurs more than the nums length divided by 2 while looping through the array. Okay, let me also remove these parts. counting occurrence. I will just leave the rest, and let's try to run. Okay, so we have a wrong answer. Output. Interesting. The first test case, 3 to 3, is the one I checked, actually. How come? Okay, so I wanna console log my dictionary at this stage. So the dictionary says 0, 1, 2. We don't have that answer, such numbers. Okay, that's interesting. What is the current? Oh, actually, for arrays, it should be off. If it is in, it will give us the indexes. Such a silly mistake. It was giving, like before, it was giving the indexes of the nums array. Yeah, I did a very, very big, like, okay, so current of numbers. But if it is a dictionary, it's in for looping. Okay, let's submit. Yeah, it passed. At this stage, once my solution passes, what I usually do on LeetCode is I go to solutions and try to find, for example, JavaScript solutions that are better than mine and check. Actually, if we go back to our description, there was a follow-up which asked us, could you solve the problem in linear time? In linear time and in linear space. This is a follow-up we should try, because right now, if we are solving it linear time, but linear space as well. Like, let's try to make it big O of 1 without using this extra dictionary. Very interesting. I have actually no clue how we can do that. Maybe I should look at the topics. Hash table, divide and conquer, sorting. I was thinking about using a sorting, but sorting mechanisms like take log n time. And our time complexity will be like n plus log n if we sort it and then check. Divide and conquer. How can we use that? We have implemented hash table and array. Okay. What do we have in the discussions? No, of course, we don't do it. But like log n, sort function uses log n time. It's not linear. It's not using any space. That's actually smart. Like if you sort it, the middle number will always be the number that's the majority. But we cannot do this. It will be like log n with that functionality. How can we solve it? Every time when you try to decrease the space, there is something you need to increase the time. You need to add. At least it will be like n plus n2 loops, but it will be log of n at the end anyway when you remove the constants. I'm thinking about like maybe we will have 2 loops, but how can we do that? Appears more than n divided by 2 times. Okay, for divide and conquer, that one thing that comes to my mind is it is an algorithm where we have a set of problem, we solve it like small subset of it. For this case, it is something like when we have this big array, we will divide it into 2 smaller arrays. For example, these 2 parts and this, and solve that the same question with smaller array, or we can even divide further and find the array that's occurring the most. I'm not actually sure how we can solve it with constant time. No idea. I would have definitely asked for hints. Not me. I'm sitting here for an hour to figure this out. Okay. Bit manipulation. Bitwise operation, maybe, yeah? That's not a good solution, yeah. Okay, let's just go to solutions and try to find the best solution. Oh, one space explanation, please. Okay, that's what I'm telling. This one is not what we are looking for. Where is our solution? No, we have on space. This is actually a scam, I would say, because he is solving on n log n time. Let me go back to the description. Is it telling linear time and in space? No, that solution is not. Do we have anything? Our solution is actually working. We need space of one space. Let's see. No. Oh, actually, on and 1. What is it? That's very smart. Ah, that's very smart. Genius. Did you get it? What it says is like, let's just take a number starting from here. Let's say we have a number here and we have a count initialized at 1 here. Like when we move, if the number is the same of the number that we are counting, like let's say current, we also have this current counting, or maybe counting, we are counting 2 and we see another 2. They are the same. We say, yeah, the count is 2. And now when we come here, we when we reach a number that's not the same as the number we are counting, we just decrement. And here we decrement. When we reach the count is 0, we also update our counting value to 1 to the number that we are counting right now. And then we keep counting that number. Is that so? So it says count is okay, element array that I. So when we come here, our count will be 0. We say now we are counting 1 and we set the count of 1 to 1 and move on. And when we see 2, we decrement it. And when we see in second 2, we see count is 0 and we say we are counting 2 again. And the number we are ending up with is actually 2. It will work because even if we have this ones before 2s are always like, there are 4 2s. We will have 4 counts, 4 increments, and then 3 decrements, which will result in 1, meaning that there will always be one more element of that majority element will always be more. That's very smart. It's like, yeah, makes sense. Actually, even if you have seen the solution, let's try to code it up. This is a very good idea when you have such when you see a good solution, try to replicate it with your, do not look at the code and copy paste, but try to write it on yourself, understanding the logic. So what we are doing is, if current equals to counting or majority element, let's say majority element, increment count, else decrement count. Also we need to check if count is 0, set majority element current. Okay, let me write my loop. For num, let num of nums. Now I know I won't be fooled again. Of nums. And also here we have some variables. Let count, which is 0, and let majority element, which is nothing. Actually, right now it's nothing, but we can just say nums 0 at the start. Okay, I will just not initialize it. And here, the first check, if count is 0, update the majority element. Well, it will be current number. And the next check, if current equals to majority element, it actually should be written in the else case, because when we are initializing, we don't want to add the same element again. Like, I'm checking current with majority element, but actually it's not current, it's number. I took this, but actually I just made this assign it majority element to number. It will always return true, and I may end up counting, like when I start at 3, I may end up counting that there are 2 3s in the array right now, which I don't want. So only if when count is not equal to 0, we wanna go to this case. Or we can just here say continue please, so that it will ignore the rest of the if statements we are writing here. If current number is the majority number element, just increment the count. Count plus equals to 1. Else, if it is not, then we want to decrement count. Count minus equals 1. Okay, and at the end we just return majority element. Okay, let's run this solution. Yes, it is working. Oh, wrong answer. What is wrong with me? Output 4, expected 3. Why did you expect 3? Count. When count is 0, please initialize. Yeah, it initializes 3. And then we check if it's a continue breaking out of the loop. No, I don't think so. Let me copy, use this test case, remove this continue, write my else. That's not the case, I believe, but let's try anyway. And is my for loop outside? Return is outside the for loop. Okay, let's just try to run it. Okay, 3 is failing. We have counted 0. We say majority element is number, which is 3 at the start. And then in the next iteration we see that count is not 0. And number is equal to that number. And count should be 2, not 1. Okay. Amendment element. They are the same. Here we should have updated the count. No, so console logs count. The session is taking more than expected. Count is always 0. Why? Are we not updating it? Is number not equal to majority element? Basically they are the same, but how come? Oh, I see. Oh, count is 0 because I am never updating it. When it's 0, I'm just doing this assignment and not updating it. That's a logical error in my code. I should actually do this. Yeah, we didn't need that extra else. It should work fine now. Okay, it's working. Yeah, so it took like 20 minutes to understand the ready solution. Insane. I hope you enjoyed the session. And the next time when you solve the LeetCode, don't forget to check the solutions for the best solution. You will always find like good solutions here, good approaches. Yeah, and don't forget to subscribe. I hope you enjoyed the session. Have a nice day. Bye.